And from here, what you can do is open in Google Colab and run the notebook after you've actually entered your API key, which is we can chat with our agent. So we just call agent.chat and we're going to ask it, tell me the best listing for a place in New York. I went to New York last year. It was okay. Decent city. Maybe I'll go back. So here is the location. Out of Manhattan. Then we have the amenities. Then we have the capacity, and it's also told us the price. And guest review of 10 out of 10.
Hi there, guys. So today we're going to be implementing an Agentic RAG system using Claude 3.5 Sonnet from Anthropic, LlamaIndex, and MongoDB. You've probably heard of RAG. You've probably heard of Agentic Systems. And Agentic RAG essentially brings this two paradigm of creating LLM applications together. So in this video, we're going to talk about what Agentic RAG is, how you can implement it using LlamaIndex and using Claude, and also using MongoDB. So you've probably followed this. If you like to read, you can actually go to the article that I put together that explains what I'll be sharing in this video as well. And I'll also be explaining more about this graph or this architecture in a second. But first, I want to clarify what Agentic RAG actually is. So I'm going to minimize myself.
So essentially what Agentic RAG is a system that leverages the RAG architecture where you have an efficient information retrieval system based on semantics of data, or you give that capability to an agent that has a large language model as its brain. And the large language model has the ability to then leverage the RAG system or the RAG capability to answer queries. But the key thing here is it doesn't have to do this every time. It can make the decision to use the RAG capabilities or use its own parametric knowledge or use other tools within the agentic system. So essentially, you're building this dynamic system that has the option to either retrieve from a knowledge base or just use its own parametric knowledge or use other tools. And the difference between the regular RAG pipeline is in the regular RAG system, you don't have the option to use the RAG or not. You always use the RAG. You always go for the information retrieval lookup step. So in this video, we're going to be building this agentic system, this agentic RAG system, and we'll be going through it step by step.
Here is that diagram I spoke about. So this is it zoomed out. And then we could just go through some of the aspects of this diagram. So first, we have the data source. This is the data loading. You load your data from different sources. It could be any sort of repositories, or it could be places like Hugging Face or PDFs. But you take your unstructured or structured data and you actually pre-process it. So in this data preparation stage, you can do things such as pre-processing, cleaning up your data, or with LlamaIndex, you can actually select which attributes of your data you want to pass into the embedding model. I'll show this as well. In this stage, you're choosing your chunking strategy and other aspects of making sure you're creating that rich document and metadata.
So with LlamaIndex, you convert all of this information, all of the data you packaged up into things called documents and nodes. These are first-class citizens within the LlamaIndex ecosystem. We'll see what this looks like in the code section in a minute. So you pass this information, your metadata, and all your attributes into an embedding model. You get your embedding based on the attributes that you've passed into it. And then you can combine the vector embeddings and the metadata and store it in an operational and vector database. So this is going to be MongoDB that we're going to be using. This is pretty much familiar to most of us that have been building RAG systems. So this is a typical RAG or part of a typical RAG pipeline. So here we come to the differentiating aspects of RAG and agentic RAG systems. So the whole RAG capability is then encapsulated into something called a retrieval tool. This is essentially packaging up the ability to retrieve documents from a database or vector database based on a vectorized query, and you're packaging this up into a tool that you then give access to an agent.
So now that the agent has the awareness of the tool that it has to use to solve tasks, the agent, you can also initialize its brain as well. The way I like to think about an agent is with the mnemonic becoming a person. So BAP. So the B is the brain, the A is the action, and the P is the perception. So the brain here is Claude 3.5 Sonnet. And this has been an impressive model. Everyone's talking about it on the internet, on YouTube, on Twitter.
The brain essentially allows for the reasoning, the planning, the tool use, the decomposition of problems, and then assigning each problem to a specific tool or knowing what tool to use for a specific problem. So that's the tool selection, the task decomposition, reasoning and planning. And at the end of the whole process, there's a response synthesis. So all of this is made available by the brain and the tool interface that LlamaIndex provides us with. So LlamaIndex also operates in the agent layer, where it gives us the capabilities to build the agent. It gives us abstractive methods and classes to help build the agents, build a tool for the agents, and essentially run the agent. And there you have this agentic RAG. Now you can expand the tool capabilities or the tool collection of your agent. You can add different tools. So here is the code. But as usual, you can always go to the GenAI showcase repository. And if you're on here, just give us a star. This signals to us that you like the content that we're uploading here. In this GenAI showcase repository, you have a wealth of content, including thought leadership content and technical content. You go into the notebook, and we have agent notebooks, RAG, workshops, and evaluation tools as well. So you go into agents and you can see the variety of notebooks that teaches you how to build agentic systems that we have. But you actually want to go into this Claude 3.5 Sonnet notebook. And from here, what you can do is you can just open in Google Colab and run the notebook after you've actually entered your API key. But I'll be going through this step by step, so you can code along, follow along. What are we actually building? We're going to build an agentic RAG system that has a capability to suggest Airbnb listings. This is a typical use case recommendation systems, but you can take this a bit further with the capability of agentic systems, where you can add more tools that can actually execute more aspects of Airbnb booking workflow. When you have the recommendations, you could build a tool that can contact the person listing the Airbnb listing itself, or you can actually build tools that can book the listing. This could be the start of your travel agent.
So everything here is very relevant for practical use cases. So let's get started. We're going to install all the libraries we need, LlamaIndex and LlamaIndex and MongoDB integration as well. We're going to be installing that. We're also going to be installing Anthropic integration with LlamaIndex and the OpenAI. OpenAI is going to be used as our embedding model provider. So install your libraries. And what you do here is also set your environment variable. Never put your environment variable as your API key or to public GitHub repository. And the first thing we're actually going to do is initialize all the models we're going to be using, both the models for the agent and the embedding model. For the agent, we're going to assign this variable LLM to the Anthropic model itself. We're going to be using Claude 3.5 Sonnet. So LlamaIndex provides us with this class that allows us to load an Anthropic model into our environment. And we do the same with the OpenAI embedding as well. So we're going to load up an embedding model, text embedding free small. The dimension of the vectors that are generated from this embedding model are 256. We'll be embedding in batch sizes of 10. And also we're going to specify our environment key here as well. And one thing I'm also going to do is just give other downstream processes awareness of the embedding model I'm using and the LLM model I'm using by using the settings class here, which essentially sets these variables at a global scope. Now we're into a very, very familiar process of data loading, where we get our data from Hugging Face. So you can always go to this link here to see what the data looks like. Next step is we're going to use the load dataset method to load our data set. We're not going to use all the data points within this data set.
we are only going to use 4,000. So this contains 50,000 or so Airbnb listings. So you can really use it to create that travel agent. Here we're going to use 4,000 and we're going to convert them into a pandas data frame, which allows us to view the data set in a very clear way. So this data set has all what you would expect from an Airbnb listing. We have the URL. So again, you can have your agent actually go into the URL. The agent we're going to build go into the URL and even pull out images or do other action within that URL itself. Then we have the description and we have other information like the availability. So one thing I want to mention is this data set is very rich. So we get text embeddings with this data set and we have the image embeddings as well. So you can really experiment with different embedding models, different type of agentic systems or RAG systems with this data set. We are actually going to remove the text embeddings because we're going to recreate new ones. I want to show you a good end-to-end process of creating RAG, agentic RAG. So what we're doing here is we're taking our data set and we're converting it to JSON. And now we have a list. We have a Python list of essentially what our dictionary is. And what we're doing is we're going to loop through this list. And for each data point, we're going to do some formatting here to make sure the data is in the appropriate format. Then what we're going to do is create a document. So in LlamaIndex, you have this concept of a document, which essentially is each data point. You can just see it as that, very, very simply described, but you have additional capabilities of specifying the actual text component of this document. So this is what's added into the embedding as well. And you can specify the metadata of this document, which we're going to pass in the full data point itself. And from the metadata, we have this excluded LLM metadata keys, which means these are the attributes you want to exclude from any language model seeing when they're actually answering queries or questions. And you can do the same for embedding models as well. So I've just listed a bunch of attributes here to exclude when the vector embedding is being created. And next, we're going to create an array of LlamaIndex documents. So, and when we're done with that, we can actually print and see what each document looks like. If you just go into the first element of this Llama documents list, you can actually run the get content method to see what either the LLM can see or what the embedding model can see. So we can see that the LLM actually sees this specific attributes. And we can also see that the embedding model sees a very defined specific attribute. So they won't see anything that we've not listed. So you can see, for example, just to make this hit home, we've removed the IDs, we've removed the transit, and you're not going to see those attributes over here. There is no ID, there is no transit data point. So this is a bit of a data pre-processing step that you can use within your RAG pipeline or agentic systems. So next, we're going to generate our embedding. We're going to be using the sentence splitter, which is going to split the text component. It's going to split it by where it determines the sentence ends. I've placed in a progress bar over here because this step can take a while. So the progress bar just gives you an indication of the progression of the embedding process. Then once this is done, you can move into the MongoDB aspect of this tutorial. And I've kept some instructions on how you can register to MongoDB. Very, very straightforward. You could create a free tier cluster and you could create a free MongoDB database. You follow these instructions here to actually deploy your first cluster. Then I need you to create a database called Airbnb. And within the Airbnb database, create a collection called Listings Review. Then once you're done creating your database and your collection, you can actually create your vector search index. So I will actually show this very quickly. So here you can see you're in MongoDB Atlas. Go into this database tab over here and you can go and browse a collection for your cluster. after you've done the creation, all the steps will take you through this. And what we're building here is this Airbnb. And this is the Airbnb database. And this is what the listing review looks like once you've done the ingestion process. So looks like I have just one, but this is okay. I can just show you the example here. So this is what when the ingestion process is done, which we'll go through later, this is what it's going to look like. I want to show you the vector index as well that you have to create. If you don't have one, you should create one by clicking on create search index. And that will take you to this JSON editor. Press next and ensure that you've selected a database, the collection, and then you can enter the JSON definition of your vector index. And I've actually kept this for you over here, so you can copy and paste this right over here. And that will be it. And you just click next and make sure your index name is vector_index. Now we can get back into the code. Once you've done all the steps, go and get your connection string. So there's a link here that shows you how to do that. And you can just get your connection string and place it within your environment. We're going to be using this frequently. So we're going to use PyMongo to create Mongo clients that allows a connection to a cluster. And from this Mongo client, this function creates a connection to our cluster, and we're picking our cluster to essentially make sure that we have a connection. And what we can do now is actually assign this connection to a Mongo client. And from the Mongo client, we can extract our database and our collection objects. So one thing I like to do is just do a bit of a cleanup. You can call the collection, which is the listings review, and call this method delete many, which deletes every record in the collection. But if you're doing this for the first time, this will be empty and it's okay. This is not going to error out. The next step is to do the data ingestion. And with LlamaIndex and MongoDB integration, this is literally just 1 or 2 lines. So you just initialize your vector store using the class from LlamaIndex and MongoDB integration. Specify the Mongo client, which is the URI we have with the Mongo client we created earlier, the database name, the collection name, and the index name. This part is important. Then after that, you could just run the ingestion in just one line, which is vectorstore.add nodes. And these are the nodes that contain the metadata for the document and contains the embeddings as well. And this will get added into the Airbnb database in the listings collection. But if you look at our diagram, we've just done this top bit, right? Just this section is what we've done. So let's move on to this other half, which includes the initialization of the tool and the agent itself. And with LlamaIndex, very straightforward. So first what we're going to do to make our vector store a query engine tool, and what we're going to do is just create an index and create a query engine from that index. We're going to specify that we only want to essentially retrieve 5 documents each time we conduct an information retrieval process. And we're going to specify the LLM we're using here as well. So we have this query engine, and rather than use this within a chat, we can actually pass this into the query engine tool. And this is another abstraction from LlamaIndex. And we can create an instance of this class where we specify the query engine, which is defined up here. And we also specify the metadata for this tool. And this metadata is also accessed by the LLM to know when to use the tool as well. So I'm giving it the name knowledge base, and I'm giving it a description here that essentially tells the agent what this tool does. And you can add some more description here to tell it when to use the tool as well. But we've just created the retrieval tool. So that is this step here. And you can create multiple tools. You can create functions as tools using LlamaIndex as well. So you can just keep creating as many tools as you want your agents to have access to. Next, creating an agent, very simple as well. We're just going to use this class, this module function called an agent worker, and we're going to use the function from tools and pass it a query engine tool, which is the one tool that we have, but you can actually pass it several tools to make the agent aware of the tools that it has capability to. We're going to specify the brain of the agent, which is, in this case, is Claude 3.5 Sonnet. And we're going to set verbose to true, which means we get very detailed outputs, very detailed logs. Next, we've created our agent worker, and we're going to essentially call it and initialize it as an agent, calling this dot as underscore agent method. And now we're ready to do the cool stuff, which is we can chat with our agent. So we just call agent.chat, and we're going to ask it, tell me the best listing for a place in New York. That is the prompt. And what's going to happen here is the agent is aware of our request, and it's aware of the tool it has access to. So it's going to use the tool that we've told it can use to basically get listings for Airbnb, and it's then going to extract some information from MongoDB. And this query essentially is going to be vectorized, and there's going to be some information retrieval based on the query. So let's see what we have. So we can see added user message to memory, and it says this is the prompt who gave it, and this is the LLM response. So certainly to provide you with the best listing for a place in New York. I went to New York last year. It was okay, decent city. Maybe I'll go back. Who knows? Then it says I'll need to use knowledge-based tool to gather information about Airbnb listings in New York. So it knows what tool it has access to. We gave it the name knowledge base, if you remember, in the metadata, and it's then going to use that tool to gather information about Airbnb listing in New York. Let me do that for you. So now it's doing its function calling, and it's going to use the knowledge base, and it's going to pass it the argument. It's actually created the new prompt to pass into this tool. It's not going to vectorize this prompt and then do a vector search on the embeddings in our listing collection. And it's created its own prompt. So the input to this tool is, what is the best Airbnb listing in New York City? Please provide details about its location, amenities, price, and guest reviews. This is going to get vectorized, and we're going to perform a vector search against the documents within our database. So the output says, while it's difficult to definitively say which is the best, but we only want the best. So it's saying that we should appears to be the newly renovated studio apartment in Midtown East Manhattan. So it's specified, it's given us a selection, which is in Manhattan. It's told us why it's given us this selection. 7 minutes walk to the subway. So it's gotten the information that is extracted from the attributes as well, and it's used this to construct a recommendation. So here we can see what the answer is, the quality, the characteristics of this apartment, of this listing, and it's broken it down. So here is the location, out of Manhattan. Then we have the amenities, then we have the capacity, and it's also told us the price. And guest review of 10 out of 10. So what we can now do, or we can create another tool, or you can even create another agent that can then actually conduct a booking, or maybe even contact the listing provider and maybe go into a negotiation message. So this could be a use case that you can create an agent for, an Airbnb negotiation agent. So it gives us the price, and it's just giving us his response. So, and it's just, I said, would you like more information about this listing? And that's it. So we have this agentic RAG, and the key thing here is, and this is the key thing I want you to take away, it knows, it's aware of the tool, and it knows when to use the tool. So you can then ask it a very different prompt that has nothing to do with listing, and it'll probably uses parametric memory and not the tool to answer the question, as opposed to then using the tool. So it has that option or tool selection capability as well. Or you can give it a new tool. Maybe you give it a calculator tool and ask it what is 2 plus 2. It's not going to use the retrieval tool to answer a mathematical question. It will most likely use the calculator tool that you've provided it with. So that is all what we have for this video. All the code is available here, and you can leave some comments and ask me any questions you have. And that's it. that's it for now. So in the next video, I'll probably explore LangGraph as well and see how to build agentic system using LangGraph. I'll be very use case focused. So I'll give you like stories or scenarios that you can build agentic system around, rather than just saying, hey, this is how you build agentic system. I'll give you like a scenario. As we progress through more videos, we're going to get more into the practical aspects of building this system and using these systems in production. So until next time, happy hacking.